Hi everyone, my name is Matt. Hopefully you remember me from the Universe Lab. So this is the second video on our Design a Lander spacecraft activity. We're going to be designing a tiny spacecraft that's going to land on the surface of an asteroid. This video is going to take you through the activity, tell you what you need to do, and give you some help as we go along. So your job today is to design a spacecraft to land on an asteroid to complete one of two missions. But there's some really important things we need to consider before that you'll need to know. First of all, we need to know the size of the asteroid. You won't need to do any maths or any calculations, but we just want you to know a little bit about the size of it. So the size of the asteroid you'll be landing on is about 1 kilometer wide. So it's a lot smaller than the Earth. And one thing you might know then is that it's going to have a much smaller gravity, a much less gravitational pull on the spacecraft. So you're going to have to find some very clever way for holding your spacecraft down to the surface of the asteroid. The other thing you need to know is your spacecraft is going to have to stay on the surface of the asteroid for 3 whole months before the end of the mission. So you need to think of things like how you're going to power it for so long, and how you're going to communicate regularly from your spacecraft back down to Earth if you need to. Now this isn't the first time we've landed on a comet or an asteroid. In fact, we've done it a few times before. Straight above me you can see a picture of the Philae lander, which you saw in our background video. And Philae unfortunately unsuccessfully managed to complete its mission. It did land on the comet, but it did bounce off a little bit first because the harpoon that was going to hold it in place failed. So you'll have to try and think of another way of securing your spacecraft to the asteroid. There are lots of other things we need to consider when we're looking at different types of landers and spacecraft. How are you going to land it? How are you going to keep it secured to the surface? There are things like balloons, but don't forget there's no air in space, so things like balloons and parachutes might not work. You need some way of communicating back to Earth. Maybe you want some kind of radar dish, or maybe some kind of laser perhaps to send information back. Maybe you want to drive around on the surface of the asteroid. Maybe you want some kind of wheels or something that can move around. There's lots of things to consider, and it's completely open to you. We want to see how amazing designs you can come up with using your pure imagination. So there's lots of things that we need to consider, and I've already gone through some of them, but I'm going to go through more of them now. So one thing we need to think about is power. How are we going to power our spacecraft, especially when it needs to be there for 3 months? There's things like nuclear power, solar panel, having batteries perhaps that are charged beforehand. So that's one possible option. Another one is movement. Do you want to move around the surface of the comet or asteroid? Do we need to make small movements when we're going through space and we're getting close to landing on the surface of the asteroid or comet? Maybe some small thrusters. The other thing is landing. How are we going to have a nice, safe, cushioned landing to make sure that nothing gets damaged? Instruments. So these are scientific equipment that maybe we need on board our spacecraft. So maybe a drill to get beneath the surface, or a microscope to look at something really, really small. Communication. How are we going to send information back to Earth? Maybe we send back things through a small antenna, or maybe we need to take the spacecraft back to Earth ourselves. And finally, utilities. Anything else? Maybe a storage box to keep samples, larger batteries to store power. There's loads of things that you might need to think about, and again, it's completely up to you. We just want to see some amazing designs of spacecraft, but these are the kind of things that you should be thinking about. There's also some questions you might want to think about before you start designing your lander. For example, what's the gravity like? That might affect how you design the landing part of your spacecraft. Is the surface stable? You might think about where you want to land on the asteroid or comet, and you might have to design different type of landing equipment based on the different type of surface. What is the surface made of? Maybe you're landing on ice, maybe on rock, maybe on dust. How much sunlight? It's great to say there might be solar panels to power your spacecraft, but if the asteroid you're landing on is really, really far out in the solar system, the solar panels might not be the best option. Finally, what's the asteroid's orbit like? If it gets really, really close to the sun at some point, you'll have much more sunlight. If it gets further away, then you'll get less. And this is what comets do, have very elongated orbits. There are lots of other questions like this you might want to think about before you start designing your spacecraft. Now, we don't want you just to design any spacecraft you want. We're going to set you 2 missions, and you have to choose one of them. And you'll have to design a spacecraft specifically that can fulfill that mission. Now, the 2 missions that we've got for you should be on the screen now. So the first mission is what's it made of. So your mission is to study an asteroid and find out more about what it's made of. To do that, you'll need to dig 30 centimeters beneath the surface, and you'll have to collect a sample. So a piece of material, such as the ice or rock or the metal which is beneath the surface, and you're going to have to bring it back to Earth. So you have to think about how you're going to access this material, how you're going to store it on your spacecraft, and eventually how you're going to get it back to Earth after the 3 months of your mission. Now the second possible mission you can do is looking for life. So your mission is to look for signs of life on an asteroid. Now to do this, you'll have to locate some ice on the surface of the asteroid. You're going to have to melt some of it to try and see if there's any microscopic signs of life that was inside that ice. Think about how you're going to melt the ice to turn it into liquid water to try and look for this life. How you're going to detect any microscopic life, and how you're going to make sure you don't damage it when you melt the ice. Those are the 2 missions you can do, so pick one of them and design a spacecraft that fits in with those mission objectives. Now what we want in the end is something that looks like this. So on a piece of paper, right in the center, we want a picture of your spacecraft. And we want you to label all parts of it. We don't just want you to name it, we want a little bit of description to go along with it, such as the communication aerial, and this area is used to communicate back down with Earth. Or the landing feet. These landing feet have springs on them to cushion the impact of landing. The more descriptive you can be, the better. Don't forget, you can always give your lander, your little spacecraft, a name as well. And also, if you have some spare time, why not draw a little space agency logo or a mission logo to go along with it. Now, we'd really love to see the designs you do. So after you've completed them, keep them around, and next time we're going to come into your school, we're going to have a look at them and we're going to see how amazing your designs are. So before you begin, this is a final recap of what you need to think about. So you're going to be landing on a 1 kilometer wide asteroid, and you're going to be staying there for 3 months. There are 2 missions you can do, what's it made of and looking for life. And the things you need to think about are the landing, the power, the movement, the communication, the utility, the instruments, and anything else that you can think of. Now, we're not just going to leave you on your own. There's some extra resources in the description beneath this video to help you out. And if you haven't seen the background video on asteroid landers, go watch that as well, because it might give you some extra information. Don't forget, keep your designs, and we'd love to see them next time we come and see you in school. Otherwise, thank you so much for watching. We really hope you enjoy this activity, and we hope to see you guys soon.